In this lesson, we'll explore the core OpenUSD file formats: USD, USDA, USDC, and USDZ. All the formats are used by OpenUSD for storing and exchanging 3D scene data. Understanding how to leverage the various file formats enables efficient collaboration, interoperability, and non-destructive editing of complex 3D scenes. USD file formats support a wide range of 3D data types, including meshes, cameras, lights, and shaders. So, first, let's go over a quick definition of USDA. USDA are text files that encode scene descriptions in a format that can easily be read and edited. It is a native file format used by OpenUSD to store and exchange 3D scene data. It is human readable, which makes USDA particularly useful for tasks that involve manual editing or inspection of scene data. This makes USDA optimal for small files, such as a stage that is referencing external content. The Quake binary format, or USDC, is a compressed binary file format used by OpenUSD to store and exchange 3D scene data. It is designed to minimize load time and provide a more efficient representation of the scene data compared to the human-readable USDA format. USDC uses various compression techniques to reduce the file size and improve loading performance. It also employs memory mapping for faster file access and loading times. The structure of the file is organized in a way that allows for efficient passing and retrieval of the scene data. USDC is extremely efficient for numerically heavy data, like geometry. A USD file can be either human-readable or binary, the advantage of which is that you can change the underlying format at any point without breaking references. Using USD is also beneficial for debugging, because an asset that is in binary can easily be changed to human-readable to take a look at what might be causing the issue. As you learn more about USD, you may decide to separate heavier data from more lightweight data. For example, a heavy scene can be large factory CAD data, or a lightweight environment that contains a single dome light. When doing so, consider using USDC and USDA explicitly to avoid obfuscation, and create large USDA files unintentionally. Let's also touch on USDZ. USDZ is an atomic, uncompressed, zipped archive so that you can deliver all of the necessary assets together. You would not use USDZ if you are still making edits to the asset, but it is a great way to package and ship your asset when it is complete. It's generally intended as read-only and is optimal for XR experiences. More on USDZ will be covered in the intermediate lessons. Each USD file format can be created through Python bindings in the OpenUSD library. When creating a new stage, you can pass in a string to represent a file name that ends in .usdc, .usd, .usda, or .usdz. For this course, we will primarily be using USDA files because they are readable, but as you work more with OpenUSD, you may choose to use USDC or USD instead. In review, there are 4 native formats: USD, USDA, USDC, and USDZ, and they are used by OpenUSD for storing and exchanging 3D scene data. All OpenUSD file formats are hierarchical and extensible based on layers and composition, which supports non-destructive editing, collaboration, and interoperability between different software tools. Any other 3D file format can be loaded into OpenUSD stages through plugins. It's worth noting that any data provider can implement file format plugins to natively speak USD. File format plugins for popular 3D file formats like OBJ, FBX, and GLTF already exist today. Developers can interact with USD files using Python bindings. Thanks for watching. Check out the following resources, and we'll see you in the next lesson.